I wish it was doing here. All right, so let's do this part. This one, this part might be mostly new for you guys, so I'm going to try to go at a relatively slow pace. If we need to do 1 or 2 extra problems at the end, please let me know. I'm happy to do them with you. Usually, if this was a real class, or if this was a class where I was live with you guys, I would do one, and you guys would do one. I would do one, you do one, and I kind of walk around as you do one to help you dig through the problems. Not everyone has a drawing tab, and so we just kind of do it this way. All right, so here we are, pre-calc 1. So we're going to do quadratic functions and models, and so this is graphing. So here, a quadratic function looks like this, where we have some ax squared plus bx plus c, where a does not equal 0. The reason a doesn't equal 0 because this equals 0. Presto, we have a linear function. So this is called standard form. This is the closest thing you have to point slope form. So this is kind of like your, this is, sorry, I gotta say this. This is the cleanest you can get it. So this is probably slope intercept. The closest thing to it would be slope intercept form for a line. This tells you the most important point, which is where the vertex of the parabola is, right? So HK, and it tells you how much you stretch or shrink it. Actually, now that we've done all the graphing of this, you guys should be, no matter what this is, you should be happy to graph it, right? Because we actually done that already by now. So there's the point. I've shifted it up, and I've shifted to the right. So there's the point of the parabola, or the vertex now. And then this is how much we've vertically stretched or shrinked it. So, but let's just start digging into it when it looks something awful. So in order to put it into this form, we're going to complete the square. Some of you may have completed the square before, some of you may have not. So let's just go over it as if you haven't. So let's go ahead and do this. So here, if I have 2x squared. So here, in order to complete the square, we're going to write this into this form. And we're going to put 22 out here. And I'm going to leave a blank spot here. But you guys probably didn't complete a square with your a not being non-zero, so we'll factor that out. So we'll factor this out safely. So we'll have 2. This is all y technically equals, right? So I'll factor this out, and so you get, so whatever your a is, go ahead and pull that out of your first 2 terms, and whatever your third term is, just kick it all the way out. Just kick it all the way out, and put in a little parenthesis here. So here we'll have, if I pull out a 2, this becomes minus 6x plus 22. All right, so if we were going to do little steps, so the first step is to make it look like this, right? So that'd be step 1. Make it look like this. Pull out your 2, right? Or whatever, in this case it'll be minus 3. Pull that out, get it to here. Then, in order to complete the square, you take, so step 2 is take your b term, divide it by 2, and then square it, okay? So in this case, our b term here is minus 6. We're going to divide that by 2, which gives us negative 3, and we're going to square it, which gives us 9, okay? And the reason we do that, because that completes the square. Let me explain why. So we're going to add 9 here. And so if I add 9 somewhere, I need to take away 9, right? Because I can't just magically add stuff on one side of an equation. But notice if I add 9 here, it's actually 2 times this 9, right? So I've actually added 18. And so when I minus 9 away, I need a minus 9 times whatever this is. Okay. And so I have this, and then you just clean it up. Y equals 2. if I factored this, technically, if you did this correctly, you should get x minus half of b, right? So x minus 3, and then also x minus 3, right? That's what it means to complete the square, because here this is just x minus 3 squared. And then if I have 22 minus 18, that is plus 4. Okay, so here I have it into standard form. Don't worry, we will do another one of these at least. Wouldn't it won't be x squared? Won't it be x squared when you take out? Oh, thank you. Thank you. That's just me not writing something. Thank you, Aaron. If I make mistakes like that, definitely point them out. Because if even if it doesn't confuse you, I'd probably confuse someone else. Yes, this should have still stayed squared. So here, when I'm doing all this, I get into this form, and here we can easily graph it. Here I'm just going over 3 to the right, 1, 2, 3, up 4, 1, 2, 3, 4, put my little dot here. And then my next point will be over and up A. So here and here, and that's good enough. All right, so let's do this whole process one more time, nice and slow, and then if we need to, we can do this. Let me actually, hold on, let me just make a new file real quick. Let me make sure. Have you guys completed the square before? Yes or no? Yay, nay? If you haven't completed it before, yes, yes, yes. I don't remember it very well. Yep. Okay. So I won't go into the nitty gritty of completing the square. We'll just do what we're doing here. If you get lost here, I can simplify it and go back. Does someone? Oh, I have one now. Let me do at least one simple one. Let me at least do one simple one then. All right. So let me go over how to complete a square. So x minus, I don't know. Let's make something that works out nicely. 4x plus 3. Okay. So let's do a very simple, very simple one, and we're going to complete the square in the form of an equation. So let's do this as simple as possible. So the point here is I want to have some a x minus some h squared plus some k, right? That's the goal. That is the goal. And so what we're going to do here in order to do that is we're going to, in order to do that, I'm going to take this part and I'm going to isolate it. And I'm going to kick this free over here. So here I've just regrouped. That's all I'm doing. So the first step is just right here. Step 1. Regroup it. Okay. All right, so that's the first step. Regroup it. So that's the very thing. The second step, step 2, is the completing the square step. This is the complete the square step. And how do we do that? We take b, whatever our b is, divide it by 2, and then square it. Okay, and so this is my b term. I'm going to divide it by 2, so it'll be minus 4 divided by 2, which is of course negative 2. Square it, and that equals 4. Okay, everyone good up to this point? Yes, no, maybe. Crickets, yes. Thank you for crickets. So I'm going to add 4 here. If I add 4 on one side of the equation, I have to take away 4. And the reason is if I add 4 and then minus 4, what I'm really adding is 0. So I'm really not changing anything, right? And so, and since there's no a here, it's fine. And so what I get here is, and so this becomes x squared minus 4x plus 4 minus 1. And the reason we call this completing the square is because this is a square of x minus 2, because x minus 2 squared produces this. And it's always going to produce this. It's always going to produce what this is always going to be divided by 2. And so we have this right here. Okay, so that's how you complete the square for a simple case. Let's do a slightly more interesting case. Same steps. So let me just get my eraser out, make it really big. Whoa. Let's go to this, let's go to that, and all right. So let's make this minus 2x minus 8x plus 7, whatever. So the first step always is going to be regroup it. So minus 2 minus 8x space plus 7. The second step is always, so here we're going to have step 1.5, and that's going to be take out your a. So take out the a. And so when we do that, I get x squared plus 4x plus 7. Step 2 is always the same. So b squared, or b divided by 2 squared. So 4 divided by 2 is 2, squared is still 4, right? So we'll add 4 here. But now when we add this 4, it's actually, since I'm adding 4 inside this parenthesis, it's actually negative 2 times this 4. So I'm actually minusing 8 out. That's really what's happening here, right? Because if I went back to this step, this would be minus 8. So if I take away 8, I have to add 8. Or a better way of seeing it is if I add 4 times negative 2, I'm going to take away 4 times negative 2, which is still the same as adding 8. This becomes always what half of b is. So half of b would be x minus, or x plus 2 in this case, squared. The negative 2 stands there. And then here I'll have 7 plus 8, which is 15. And so we've done that. Okay. So here's another 2 examples of completing the square. So let's go back and do one last one. So we'll go through these steps slowly. So here I'll have minus 3x squared minus 12x space plus, or minus 10 in this case, minus 10. So that's my step 1. We're going to do step 1.5 because we need to. This becomes minus 3x plus 4. I guess I've gotten plus 4 one too many times. Minus 10. I forgot how you simply factor it down to this. Oh, okay, let's go back to that real quick. So here, once you get to this point, you can always just factor. You can always just factor because you'll get, here I'll get x plus 2 and x plus 2, right? Or you can always just say whatever this is, whatever b is divided by 2, that's what this is. So it'll be x plus b divided by 2 squared. It's always the same. You didn't put the square on the square? Oh, I probably missed something somewhere. Oh, probably back on this one. Yes, thank you. So here, I'll go through the factoring really slow this time. So here once again, this is 4 divided by 2 squared would be plus 4. So if I'm adding 4 here, I need to minus 4 here, but I also need to multiply it by negative 3. So here I'll have minus 3. Here, if I'm factoring this, if I was going to factor this the old school way, just real quick, I'd have x, divisors this is 2 and 2, which adds up to this, so it'd be x plus 2, x plus 2. And so here I'll have x plus 2 squared. And then 10 minus a negative 12 would be plus 2, so it'll be 2. And so here we have it right here. Okay. Yeah, so here we go. So we can graph this. So it's at, remember, to the left 2, even though it's positive, and up 2. And here I'm going to go over 1 and I'm going to go over 1, and then I'm going to traverse my a, which in this case is negative 3, right? Because here my a equals negative 3, right? Negative 3 is my a, and so that's how much I've and this is my horizontal stretching or shrinking. So here I flipped it and then stretching it by this much. Same for over here, over 1 down this. And so here I can roughly sketch in my graph. Okay. All right, so let's go ahead and to the next page. I'll leave it up for 1 second so you guys can copy, but let's go to the next page. All right, so the question is, can we just do this? Can we do this without knowing the numbers? The answer is yes. It gets a little ugly, but let's just crunch through it. Don't worry about doing this personally. It's just something I want to show you. So it's just kind of like follow along for a second. So here, let's just go through this for steps. So step 1 is regroup it, right? So we'll have a x squared plus bx blank plus c. So that's my first step. I'm going to regroup it. My second step, or 1.5 step, let's do 1.5, is pull out the a. So I'll have a x plus b over a x plus c. And then can I figure out what that is? Yeah, sure. It's just, this would be b over a divided by 2 squared. Which of course, if I simplify this down, the 2 just goes into here. So it's just b over 2a squared, which is the same thing as b squared over 4a squared. So I'm going to add b squared over 4a squared, and I'm going to minus out b squared over 4a squared times a. So I can cancel out one of these a's. And then I can factor this. This will be a x plus b over 2a squared plus the quantity of c minus b squared over 4a. And the reason I show you all that and go through all that is now we have a formula, right? So define, and this is my vertex point, right? This is my x, this is my y, right, for my vertex. And so to find the minimum maximum value creates at a vertex. So here the x value is this, b minus 2a. Because remember, you switch this one, right? Because it's x minus h plus k gives us our hk before, right? X minus the h. Because the reason is when we go in the positive direction, we're actually going in the negative direction for the shifting. So here's my vertex, and I can just plug, and there's 2 ways. Either I can crunch through this number is a perfectly fine way, or you can just plug it into the actual function itself. So you can actually take that and plug it through the function. You can find out where your vertex is. So you actually don't have to do all the work to figure out where your vertex is. Oops, let's go back. So find the minimum and maximum value. So if a is positive, you'll have a minimum value. If a is negative, you have a maximum value. And the reason is if a is positive, it's going to open upwards. And so you only have a minimum value. The maximum value is infinity, right? And if a is negative, as it is here, it's going to open downwards. And so you only have a maximum value, and then it does that. So let me explain kind of what I want you guys to get at real quick. So here, find the minimum maximum values of a function and graph them. All right, so if we're going to do this, what is, so here our x would be for this one. Our x, we can just use this formula. So x is going to equal to minus b over 2a. Well, a in this case is 1. A is equal to 1. B is equal to 4. So the x coordinate is going to be minus 4 over 2 times 1, which is just negative 2. Then I can plug it into the function. So f of negative 2, if I plug that in, I get negative 2 squared, which is 4 plus, let me actually just do it, negative 2 squared plus 4 times negative 2. So this is 4 minus 8, so that equals minus 4. So here I know what my vertex is, 2, negative 4. And I didn't have to complete the square. I didn't have to do anything really fancy. You can just crunch through it this way. It's just another way of hitting the same goal. And so here I have my vertex. So here at negative 2 in the x direction, negative 4 in the y direction. In which way does it open? Well, it opens at 1. So I can quickly graph this. Actually, I know where the other points are at. And so I can just quickly graph this by finding the vertex. Here, once again, we can crunch through this quickly. We can just say x is equal to minus b over 2a. So in this case, a is negative 1, b is 1. So here I'll have x equals negative 1 over, or minus 1 over 2 times negative 1, which of course is just a half. And here, given a half, I can then plug f of a half in. And so here I'll have minus 1 over a half squared plus a half plus 2. So that gives me a fourth plus a half plus 2, which is the same thing as a fourth, plus 2 fourths plus 8 fourths. So it gives me 9 fourths. Not super nice and clean, but here I have my vertex at a half and 9 fourths. And the part where this really shines, the reason why you'd use this over completing the square for this gets kind of not fun. And this you can just crunch into a calculator. You can just crunch this through a calculator, right? You can take this number, crunch it, and then you can just plug it into your function, just so it's easier for a calculator. And so once we do that, I can just we can just go over a half and then 9 fourths, which would be a little bit over 2. And then here it's just over 1, down 1. And then over 1, down 1. And then here we kind of have our graph here. Okay. So these are just finding mins and maxes. You just literally use the formula here. You just plug it in, chunk it through, and then just type this into a calculator. So just type this in a calculator. It's easier than completing the square, in my opinion. If you have a calculator. If you don't have a calculator, completing the square is just as easy as doing this. All right, so let me do one simple word problem with you, and then we'll answer any lingering questions, and then we'll be good to go. And then you're gonna go home and work on, or not go home. We're already all home. Isn't that the truth of it? Some things are still left over from my teaching in 5 days. When you work on it tonight on your own, you will you'll have a chance to practice, and that should help things quick. If not, ask your friends. If not, ask me tomorrow. If not, ask me on Friday. We have set times for you to ask questions, but you need to go practice it to figure out what you're missing. All right, so a gas mileage of a car is based on speeds, assuming many factors are constant. The following functions for miles per gallon for a given speed of a car is given by this formula, which is actually not bad, especially between 14 and 70 miles per hour. It is kind of like this. And most of you have a little, when you're driving your little car, some cars have it, not all, but have a little like how many miles per gallon you're destroying. That's because the car knows what it's putting in and knows how fast you're going, so it just crunches the calculation. So let me just get a little bit of feedback from you. Assuming many factors are constant, so what other factors besides the speed of your car determines the miles per gallons of the car you're driving? Just give me a couple, just to see if you guys are awake. What other things change the miles per gallon besides the speed? See if anyone has weather. Weather's true. Yeah, so the weather will definitely change it. So if you're in high humidity, the air resistance of your car is actually higher because you're pushing through a thicker liquid. The incline definitely matters because you're going uphill. The weight of your car. I have a cute little Honda Fit, and I have some big brothers and big brothers. And so it's just me and my little Honda Fit. It was fine, but when you add, another, we stuffed that car. We stuffed that car with like a couple people, right? Looked like a little clown car, and we put an extra like easy thousand pounds of human in there. Definitely changes. So yes, the weight of the car is definitely that. There's other things that can the friction of the road. So if you drive it through sand, miles per gallon just goes to garbage compared to asphalt. There's a lot of things, the weight of the car, the heat of the car. There's a lot of things to go into, but this makes a good assumption. So if we want to know where the best miles per gallon we can achieve and what speed this occur, what do we want to know? We just want to know what the vertex of this is, right? This is a quadratic form, so all we care to know is the vertex. Aerodynamics, yes, the aerodynamics of the car. So if I take my car and all of a sudden I put a mattress on top of it, it doesn't really change the weight, but it destroys the aerodynamics, right? So there's a lot of things here. So here we have a vertex, and so here we want to find the vertex, because this is a function which opens down. So the vertex, so here quickly in my little brain, I know this is a quadratic graph that opens down. I want to find the best miles per gallon, so I want to know what the max point is. Well, the max point is going to be the vertex. Well, how do I find the vertex? Well, I have how to find that. S, because notice here, if I wrote this as y is x, this would be x squared, but here S is my thing. So S is equal to minus b over 2a, because that's when I plug it in. It's my speed. It's now my variable. Here, minus b is -3 over 2 over 1/28. Let's see if I can do this in my head. So -1/28. So the negatives indeed cancel. If I divide by 1/28, it's the same thing as multiplying. So it'd be 3 times 14. 3 times 14 is 42. Okay. If you can't do that, you have to type it in your calculator. By all means, type in your calculator. So that's what speed it occurs is at 42. But what's the miles per gallon? Well, we have to crunch through it. So m equals, so we'll just plug it into the formula. So minus 1/28 over 42 squared plus 3 times 42 minus 31 equals, and here, just crunch it through a calculator. Literally crunch it through the calculator. If I was going to do this without crunching this through a calculator, I'd tell you, I'd split this into 14, 3 and 14. And then square 3, square 14, cancel off of 14 here. Just put it in a calculator, you're going to get 32, right? So you're going to get 32 miles per gallon is the best this car achieves. At, and that's at, actually really right, which occurs at 42 miles per hour. Okay. So that's how you do the word problem. And so you may or may not see something like